Okay, I was in lecture 5 and 6 in the previous video, and I did some part of the lecture note in the previous lecture video. And here now I'm going to continue this lecture, and this will be the sixth lecture, lecture 6. Okay, see, we did up to these questions. We construct the truth table for conditional statement P imply Q, and we did this truth table, and also we did the truth table for negation of Q imply negation of P part. So this question, and before this we did some other truth tables, like we did let me see, we did the truth table for the negation of a statement and double negation, and we did the and the statement and statement, the truth table for and statement, and we did the truth table for or statement, right? So we did these things, and we did some other questions where we solved we got the truth values of these statements, this statement and negation of P and Q, P or negation of Q, negation of P or negation of Q. We got the truth values of these statements, and then then we did these truth tables, the truth table for negation of P and Q. This is what we did, and also we did the negation P or Q and negation of Q truth table. So we completed these things before. Now in the sixth lecture, I'm going to continue with the lecture note and solve the remaining questions. Okay. The next question is construct a truth table for this statement. Okay, so P or Q and negation of P, and that whole thing implies Q. Okay, so we have two statements P and Q here. Again, P and Q. We don't have third statement, because sometimes we may have third statement like P, Q, R, like that, right? So if there are three statements P, Q, and R, we'll get 8 cases. So I'm not going to do that thing now for this question. We just have P and Q, and if we have P and Q, we get 4 possible cases, right? So if there are 3, then we get 8, and that's how we keep going. But we have only P and Q here, so don't worry, we just have 4 possible cases. So we have P, Q. So we start with P and Q. Okay, so we start with P and Q. Now so we have to get this thing, right? So we have to get this thing. So first we get P and Q. Now I'm going to get this part, P or Q. So I put that P or Q. So we do this. Okay, and negation of P. So I can find negation of P, and then I can combine. Then I can combine these two with AND symbol. P or Q, which is this part, and negation of P, which is this part, right? So I get up to this part. Now finally I'll find out these things. I will find out this P or Q and negation of P implies Q. Okay, so what I'm doing here is I'm not doing anything big, like I'm doing step by step. I'm doing step by step. So I'm doing P and Q are in the question, always it is the starting place of any truth table. P or Q, because here is P or Q. So I did this part, and then I combine this part with this part, negation of P. But to do that, I need negation of P. So I put a negation of P column, and then I combine these two to get this thing, right? So to get this part, and then when I get this part, then I did that this implies Q. Okay, so that's how I set up the headings, the headlines. Okay, the topics. Now, P can be true, Q can be true, P can be true, Q can be false, P can be false, Q can be true, this can be false, Q can be false. Okay. Now P or Q. What is P or Q? True or true is true. True or false is true, because this is OR statement, so at least one of them is true. It is true. False or true is true. False or false is false. So P or Q is true, 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 false. Now negation of P. Negation of P. So look at P column. P is true, negation of P is false. P is true, negation of P is false. This is false, so negation is true. This is false, so negation is true. Okay, so negation of P is false, false, true, true. Now I find P or Q, which is this one, and this one. So true and false is false, because this is AND. So AND is true. To be true, the AND is true if both are true, right? So because this is true and this is false, it has to be false. True and false is false. True and true is true. False and true is false. Okay. All right. Now I have to find this imply Q. So this imply Q. Q is here, right? So Q is this. True, false, true, false. This is Q. Now this implies this. When there is if then symbol, this implies symbol, you will get false if this part is true, and if this part is false, then you get false result. If the first part is true and the second part is false, then you get false. So if this is right, so if this part is true and if this part is false, then you get the false result. Otherwise you always get true result, right? So let's see. This is false. This part is false and Q is true. See, false and true is true. Okay, so this implies this, not this implies this, but this implies this. Okay, so false implies true is true. Now false implies false is true. True implies true. So true implies true. So this implies this is true. False implies false is true. Okay, so here is no false. All are true. All truth values are true. Okay, so again what I did here, how I get true, 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 because I look at this which is here. So I look at this column and I look at this column. Okay, so I look at this column first, and then I look at this column Q. Okay, so this column is this implies this. So this implies this, right? So false imply true is true. True. False imply false is true. True implies true is true. And false implies false is true. It could be false if this was true. No, if this was, yes, if this was true and if this was false, then it could be false, right? So what I said here is, if this part is true, if the first part is true and the second part is false, then it is false. But we never get that situation here. We never get that case. Okay, so we got the false and true. So true. False implies false is true. True implies true is true. And false implies false is true. So we get all true. So it is possible that sometimes we get all true, sometimes we get all false. It is possible. Okay. All right. So this is the truth table for this statement, this compound statement. Okay. Now biconditional statement is double implication. It is P and both way arrows. The arrow goes both ways. See this arrow goes both way. P if and only if Q. P if and only if Q, which means P implies Q and Q implies P. So this is the meaning of double implication, double implies, biconditional statement. Okay, so this is conditional statement and another conditional statement. So when we combine these, we get the biconditional statement, and that biconditional statement is P if and only if Q. So this is the notation for biconditional statements. And this is true only when the component statement have the same truth value. Okay, so this is important to know. This is true only when the component statement have the same truth value. So what does that mean? If P and Q are both same, if P and Q are both same, then P double implication Q means biconditional Q. P biconditional Q is true. So if they have same thing, like if it is true and true, then it is true. If they have false and false, then it is true because they have the same thing, right? So if they have same thing on both statement, then it is true. If one of them is false, one of them, if they have different values, then these are false. Otherwise it is false. The truth table for this is okay. So construct a truth table for the biconditional statement P double implication Q. Biconditional statement. Okay, so how do we construct the biconditional statement P double implies Q? So we have P Q and P double implies Q if and only if Q. So it can be true, it can be true, it can be true, it can be false, it can be false, it can be true, it can be false, it can be false. Okay, so this is true only when this is true if both P and Q have same thing. Okay, same thing. So true, true, true. False, false, true, because they are the same thing. True, false, false. False, true, false. So this is the truth table for double implication biconditional statement. Okay, so if they have the same thing, true. False, false, true, 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 because they have the same thing. If they have a different thing, then it is false. Okay, so let's go to the next page. Okay, now we did the conditional statement if P then Q, and we also did the biconditional statement. From a conditional statement, for any conditional statement, we can have its converse, inverse, and contrapositive statements. If P imply Q is the conditional statement, then Q imply P. If we switch Q and P, then that statement is called the converse of this conditional statement. Okay? If we find the negation of P imply negation of Q for any conditional statement P imply Q, then this statement, negation of P imply negation of Q, is called the inverse of P imply Q. And negation of Q implies negation of P. If you switch P and Q, and if you put a negation symbol for both, then this is called the contrapositive statement of this conditional statement. Okay, so how do we find, and what types of question we get for these things? See, here is the question. If you are sleeping, then you are breathing. Okay, so if you are sleeping, then you are breathing. This is a conditional statement, right? So if, then, this is conditional statement. Write its converse, inverse, and contrapositive statements. Okay, so you see, here are two statements. If you are sleeping, then you are breathing, right? So let's assume that P is the statement you are sleeping. You are sleeping is P. You are breathing is Q. Okay, so we that's why it is if P then Q, right? So if P then Q. So if you are sleeping, then you are breathing. So P is you are sleeping, Q is you are breathing. Now the conditional statement is the statement which is given. This statement is conditional statement. If P then Q. Okay, so we can write just P imply Q. So this is if P then Q. So this is if P then Q, right? So this is what we have here. If P then Q. So this is the conditional statement. Okay. But the question is find converse, inverse, and contrapositive. And conditional statement is given in the question. Converse. What the converse look like? The converse looks like this. Q implies P. To be converse, we need to have Q implies P. Okay? Q implies P is if Q then P. So this statement is converse statement. And what is this statement? If Q then P. So the converse of this statement is if you are breathing, then you are sleeping. Okay, so this statement is converse statement of if you are sleeping, then you are breathing statement. So this is conditional statement. Its converse is if you are breathing, then you are sleeping, because the converse is Q imply P. Now the inverse is negation of P implies negation of Q. So negation of P implies negation of Q. So this is converse, and this is if not P, then not Q. Okay, so the statement is if you are negation of P, so this is P, right? So if you are not sleeping, then you are not breathing. So this statement is the inverse statement of this conditional statement. So the inverse has to be negation of P implies negation of Q. And the contrapositive is negation of Q implies negation of P. So you switch P and Q. The Q will be first statement, and then the negation of P will be the second statement. So this is okay. So let's write this statement, because this is this arrow says if then, right? So if then, so if negation of Q is you are not breathing. If you are not breathing, then you are not sleeping. Okay, so this statement is contrapositive statement of this statement. If you are sleeping, then you are breathing. So to get contrapositive, you have to switch sleeping and breathing. So we switch the P and Q part, and then we put the negation symbol on both. Okay, so that's how we get the converse, inverse, and contrapositive. To be converse, we interchange in the Q and P part, P and Q statement. To get inverse, we put a negation on both, and to get contrapositive, we interchange P and Q, and we put negation symbol on both. Question. Given two statement P and Q, which has the conditional statement P imply Q, construct a truth table for its converse statement Q implies P. Okay, so the question is construct the truth table. Construct a truth table for the converse statement Q implies P. Okay, so we have P, Q for the truth table, and we are going to find Q imply P, the truth table for Q imply P. Q implies P. Okay, so we find the truth table for this statement, and this statement is the converse statement. So we have true, 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 false, false, true, and false, false. Okay, so be careful. The first part here is Q and the second part is P. So let's do in Scratch. So we have Q and P, right? So if this is true and this is false, then only we get false, and otherwise true. Okay, so conditional statement we always get like this. The first one, if the first one is true and the second is false, then we get the false. So first is Q implies the second statement is P. Okay, then it is false, otherwise it is true. Okay, so true implies true. The first is true, the second is true. True. Okay, so you have to go from Q to P, not from P to Q. You go from Q to P. True implies true, true. False implies true is true. True implies false is false. See, Q is true, P is false, right? So Q is true, P is false, then it is false. So true implies false is false. False implies false is true. So this is the truth table for converse statement Q imply P. So if it is a P imply Q, then we look at this implies this. So true implies true, true implies false, false implies true, false implies false. We do that way. If it is Q implies P, then you have to look at this first and then this second. So the first and second. So first implies second. So true implies true, and then false implies true, and then true implies false, and then false implies false. So that's how we have to go the opposite way. Okay. Construct a truth table for its inverse statement. Negation of P implies negation of Q. Okay, so we draw the truth table for negation of P implies negation of Q. So let's start with P. Q. Negation of P. Negation of Q. And then negation of P implies negation of Q. So it can be true, 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 false, false, true, false, false. Negation of P is false, false, true, true. Negation of Q is false, true, false, true. Okay, now we have the conditional statement here. Negation of P and negation of Q. So we look at these two columns. Okay, and we are going from negation of P to negation of Q. So we are going from this to this. So let's do the scratch. If it is a negation of P implies a negation of Q, then if this part is true and if this part is false, then it is false, otherwise true, right? So otherwise true. Okay, so negation of P to negation of Q. So this implies this. False, false is true. False implies true is true. True implies false is false. True implies true is true. So we got the table. Okay, so this is the table for the inverse statement. Okay. Now, given two statement P and Q, which has the conditional statement P imply Q, construct a truth table for its contrapositive statement. Negation of Q implies negation of P. Okay, so let's see. We have P, Q, negation of, let's start with the negation of Q. We can put negation P, we can find negation of P first, negation of Q first. It doesn't matter. We only need to, we focus on this part only. So we have to get this thing at the end. So we can do negation of Q first and then negation of P. And then negation of Q implies negation of P. Right? So true, 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 false, false, true, false, false. Negation of Q. Q is here. So negation of Q. False, true, false, true. Okay. So Q is true, negation is false. Q is false, negation is true. So true, then false, then false, then true. Okay. So negation of Q is FT, FT. Okay. Negation of P. So look at P and find the negation. So it is false, false, true, true. Okay. Now negation of Q implies negation of P. So now we need to find this implies this. Okay. So let's do the scratch work because this is conditional statement. We have negation of Q implies negation of P, right? So if this is true and if this is false, so if this part is false, if this part is true, then true implies false will be false. Otherwise it is true. Okay, so because we are going from this to this, false to false is true. True implies false. True implies false is false. So true and false. False. Okay. Now false implies true will be true and true implies true will be true. So true, false, true, true. Okay. Alright. So let's go to the next page. So we have two more problems. Two more questions. Logically equivalent statements. Two statements which have same truth values are called logically equivalent statements. For example, P implies Q and negation of Q implies negation of P are logically equivalent statements. We can prove they are logically equivalent by means of truth table. So we draw truth table for negation of Q and negation of P, and you draw truth table for P implies Q. If their values are same, then these are logically equivalent. Then these are logically equivalent statements. Okay. Here is the question. Prove that these are logically equivalent statements. Okay. So this and this. So let's see. So let's draw the table to prove that these are logically equivalent statement. So we have to have P and Q. So P, Q, and then let's do this part. P implies Q. Okay, we can put both in the same table. We don't have to draw two separate tables. Okay, we can show both in the same table. Okay, so this is P implies Q. Now to find this one, so we got this one. Now to find this one, we need negation of Q. So let's find negation of Q, negation of P, and then negation of Q implies negation of P. Okay, so it can be true, 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 false, false, true, and false, false. P implies Q. P implies Q is true, true implies true is true. True implies false is false. False implies true is true. False implies false is false. Right? So that's how we have been doing. So this is when the first is true and the second is false, then it is false. So when it is always the case. So in any conditional statement, true implied false is false. Otherwise, other are true. Okay, so true implied false. So here true implied false is false and the other are true. So sorry, this is true. So yeah, that was mistake. So this has to be true. Okay, so false implies false is true. True implies false is false. Okay, so we get true, false, true, true. Now negation of Q is false, true, false, true. Negation of P, false, false, true, true. Okay, now let's find this. So Q, negation of Q and negation of P. So this to this, right? So false to false. False implies false is true, because true implies false only gives false. Okay, true implies false is false. False implies true is true. True implies true is true. Okay, so we got the truth values for negation of Q imply negation of P, which is this, and we got the truth values for P imply Q, which is this. Now look at these two things. You get the same thing. You get true, false, true, true. You get true, false, true, true, because these are same. This statement and this statement are logically equivalent statement. Okay, so we can write since the truth values are same for P implies Q and negation of Q implies negation of P, these are equivalent, logically equivalent statement. Okay, so this is the thing. So if you get the same thing, they are logically equivalent. Are these logically equivalent, these two, negation of Q and negation of P? No, because this is false, true, false, true, and this is false, false, true, true. So it has to be same. Okay, it is not like two of them are false, two of them are true. It doesn't work that way. It has to be exact same. False, true, false, false, then it has to be false, true, false, false. Then it is logically equivalent. Like here, you have false, true, false, true, true. You get true, false, true, true, right? So they are logically equivalent because they get the same truth values. Okay, now finally, tautology. Tautology, if the truth values of a statement are all true, then the statement is called a tautology. So what does it say is, like when you find a truth table, like this one, if you get all true, like true, 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 or if you have all true, then that statement is called a tautology. We had one statement that we did before, which had all true, 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 true. So that was a tautology. Okay, this is not a tautology because here is one false. So if you get all true, then it is a tautology. The question is, prove that the statement P or Q and negation of P imply Q is a tautology. Okay, so we did this statement before, but let me do it again. P, Q, P or Q, negation of P, P or Q and negation of P, and P or Q, and negation of P implies Q. Okay, so true, 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 false, false, true, false, false. So these are the cases, the possible cases. Now P or Q, true, 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 false, true. If you remember, this is true when the OR is true when at least one of them is true, right? So at least one is true, so true. So F true, false true is true, and false false is false. So this is true, 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 false. Negation of P is false, false, true, true. Okay, now this and this, this and this, and for AND you have to be, it has to be both true, right? So true and false is false, true and false is false, true and true is true, false and true is false, right? So we get this thing. Now we need to find this imply this, so this imply Q, right? So that we have to check. Now false implies true, false implies true is true, because always we need to be false, it has to be like a true implies false, true implies false is false, and the other are always true, right? So here false imply true is true, false imply false is true, true implies true is true, and false imply false is true, because we never get true implies false. So when it is true implies false, then it is false, but we never get true implies false. We got only one true here, and here we have another true, so true implies true is true. So we get all true, right? So here, because the truth values are all true, the statement, this is statement P or Q and negation of P implies Q is a tautology. Is a tautology. Okay, so this is the tautology. If you have all true, then the statement is a tautology. Okay, so we are done with lecture 6. I will see you in the next video. Please practice these truth tables. You can see some other videos from YouTube. You can see some truth table videos if you find them easier or helpful. You can do so. I will see you in the next video. Okay, I'll see you then. Bye.